For this video, I'm going to solve some rational inequalities. It's going to feel pretty similar to how we looked at polynomial inequalities. There'll be obviously a little bit of things that are different, but you'll kind of feel like it's a little bit similar to stuff that we did at the end of the previous unit. Okay, there's only three that we're going to go over. So this first one here, example one, kind of the first thing I do with these is you want to make sure that you'll have 0 on one side of the inequality. So you'll notice I have 4 here. So I'm going to move that 4 to the other side with subtraction. Now, because this is really 4 over 1, I'm going to get a common denominator, right? I need this to be x minus 3 as well. So for that to happen, I'm going to multiply in the top by x minus 3 and in the bottom by x minus 3. So doing that means that I'm going to have negative 4 times x minus 3 on top as well. Let's go ahead and distribute the 4 with the negative to get negative 4x plus 12. And now that we have the same denominator, we can go ahead and combine to get our new expression here, negative 4x plus 18 over x minus 3. Okay? So now what I'm going to do is I am going to focus on this, and this is greater than or equal to 0. All right? And I am going to factor out that negative in the numerator. All right? So actually, let me copy this and move it up. Copy this, move it up here. And I'm going to factor out that negative on top to get 4x minus 18 over x minus 3. And I'm going to move it to the other side with division. And you'll notice that 0 divided by negative 1 is going to be 0 again. But if I move, or if I divide by a negative or multiply by a negative, I need to change the inequality symbol. Okay? Okay, so now from here, I'm going to draw a number line. All right? Where I have negative infinity going to infinity. And really I have, in this case, two things that I care about. I care about what's happening in the numerator, because if you remember from our notes on graphing, if we make the numerator become 0, that's going to be an x-intercept. So if I set 4x minus 18 equals 0, that's going to tell me something interesting about this inequality. So I have 4x equals positive 18, so x equals 18 over 4, which is really 9/2 or 4.5. So I'm going to put right here 4.5. You can put 9/2 if you want. Something interesting is happening there. Now, you also hopefully remember that if we make the denominator equal to 0, that's going to be where the function is undefined. All right. So I'm also going to put at 3, I'm going to put that there because something interesting is happening at that spot. Okay. So now with this, all right, I'm going to put open circles or an open circle at 3 because that's where we would have 0 in the denominator. And because it says or equal to, I'm going to put a closed circle at 4.5 because that would make this whole thing become 0. Okay. Now, when I figure out what's happening with in between these values, it's going to feel like using those critical points and test points like we did with polynomials, like I mentioned before. So I'm going to plug in a value that is between negative infinity and 3. So that means I'm going to plug in 0. Okay, so I'm going to plug in 0 here. All right, and again, I don't care about the actual value. I just care about the sign, whether it's positive or negative. And I'll be plugging into this 4x minus 18 over x minus 3. So 4 times 0 minus 18 over 0 minus 3. Right, so in the numerator, that's going to be negative 18. In the denominator, that's going to be negative 3. A negative over a negative is going to be a positive. So if I do the same thing here, all right, a number between 3 and 4.5, I'm going to choose 4. So 4 times 4 minus 18 over 4 minus 3. So in the numerator, that's 16 minus 18, which is a negative number. 4 minus 3 is a positive number in the denominator. A negative over a positive is a negative. And last but not least, you can choose any number between 4.5 and infinity. I'll just choose 5. So 4 times 5 is 20. 20 minus 18 is a positive. 5 minus 3 is 2. That's a positive over a positive, which is a positive. Now, ultimately, to finish this question, I'm looking at what my symbol ended up becoming, which is less than or equal to 0. So I'll be looking at the signs that I wrote for the ones that are negative. There's only one, and because it does have or equal to, like we mentioned in the unit with polynomial inequalities, we got to make sure that if it does become 0, we have to include that. But you already know the only one that mattered was 4.5, which is going to be a part of this interval, so I don't need to worry about adding something else. So the answer for this are your values that are between 3, and I'll just go back to 9.5, but you can write 4.5. And notice I put a bracket around 9.5 because it is included, and 3 I did not include that because it is an open circle. So that's kind of the way that I want to approach doing this. And I know it's a lot of work. I'll try to give you more space when I ask you to do it on your own. Okay, let's go to example 2. Kind of very similar to what we started with. This doesn't have 0 on that one side, so I'm going to go ahead and move that 4 over with subtraction. Getting a common denominator, I'm going to go ahead and try to skip a few steps here to try to go a little faster. So we're going to plus negative 4 times the 2x minus 3 over 2x minus 3. Hopefully your brain is seeing why I wrote that. Ultimately, I need to get the same denominator. So that's 3x plus 1. That's going to be minus 8x plus 12 over 2x minus 3. Adding the stuff on the top, that's negative 5x plus 13 over 2x minus 3. Like I did before, right now this is less than 0. Like I did before, I'm going to factor out the negative to get 5x minus 13 and move that to the other side. And when I divide both sides by that negative, I get 5x minus 13 over, excuse me, 2x minus 3, and it's going to change to be greater than 0. So this is ultimately what I'm looking at to kind of finish the problem. I'm going to draw my number line. I've got negative infinity here, positive infinity here. And if I look at my numerator and my denominator, right, numerator, if I set that equal to 0, put it up here. So 5x minus 13 equals 0. 5x equals 13, so x equals 13 fifths, which as a decimal is going to be 2.6. So I'll put that here, 2.6. All right, notice that this says just greater than. It doesn't have or equal to, so I'll be using an open circle for that. I'm going to set my denominator equal to 0. 2x minus 3 equals 0. So that's going to be x equals 3 halves, or 1.5. So I'll put 1.5 here. And that one also will be open because we can't have the denominator become equal to 0. All right, so that is where I get those two values there. And then it becomes plugging in to see what's happening in those different intervals. So I'll start with this first one. I'm going to plug in something between negative infinity and 1.5. I'm going to choose 0. So 5 times 0 minus 13 over 2 times 0 minus 3. That's a negative 13 over a negative 3 was actually a positive. Now the next one's a little bit tight here, but I'm going to do 2. So 5, did not mean to erase that, I apologize. I'm going to do 5 times 2 minus 13. Let me get this actually out of the way. Over 2 times 2 minus 3. All right, that's going to be 10 minus 13, which is a negative. And then 4 minus 3 is a positive. When you divide that, you get a negative. And last but not least, I'll use, let's see, 3. So 5 times 3 minus 13 over 2 times 3 minus 3. So that's going to be 15 minus 13 is a positive. 6 minus 3 is a positive. So that's a positive over positive, which is positive. We are looking for greater than 0 here. It doesn't have or equal to, so I don't need to worry about any issues with that. So my positive values are going to be if my values are between negative infinity and 1.5, and then do the union symbol, and then 2.6 to positive infinity. All right, so this is going to be my answer for the second one. Let's do one more example. All right, I'm going to move over the 12 over x plus 1 with subtraction. Now this one is kind of nice because we already have, the same denominator. So I can just do 5 minus 12, which is negative 7 over x plus 1. But like I did before, I'm going to divide that negative to the other side to make this less than 0. All right, so using that, if I set my denominator equal to 0, I get x equals negative 1. And my numerator, right, if you look at the numerator here, there's no variable up there. So there's no way to make that equal to 0. So I'm just going to have that negative 1 is my only one that I care about. It is negative 1 would make the denominator 0, so I'm going to use an open circle. And we have negative infinity to positive infinity. All right, so plugging in, I'm going to plug in, 0 here. So 7 over 0 plus 1, that is going to be a positive. And then I'll plug in 2. So 7 over 2. I don't know why I plugged in 0. 0 is not there. I apologize. Let me back up here. Sorry about that. 7 over, let's plug in negative 2. There we go. 7 over negative 2, which is going to be 7 over a negative 1, which is a negative. That makes more sense. And then I'll plug in a positive 2, or I can plug in 0, but I started with 2. So 2 plus 1 is 3. That's a positive. Positive 7 over positive 3 is a positive. All right, so when I'm looking at the answer to this, I'm looking for less than, which is going to be negative. So it's going to be negative infinity to negative 1. All right, so that is how you solve these rational inequalities. I've got some homework questions to try. Come see me if you have any questions.